Good morning to all of you. In this video, we will be delving into the fascinating topic of the application of advanced ceramics in the automotive field. Firstly, I would like to introduce ourselves. I am Angie, and joining me today is my partner Jasper. Together, we will be guiding you through this informative presentation. After this, we wanted to take a moment to share a glimpse of our personal experiences and journey as a ceramic engineering students at MSU-IIT. We have prepared a short presentation that highlights the journey and experiences of our growth and achievements we have encountered during our time as students in this field. So without further ado, let's dive right into our discussion on the application of advanced ceramics in the automotive field. Advanced ceramics are a class of ceramic materials that possess exceptional mechanical, thermal, and electrical properties. These properties make them highly attractive for use in a wide range of applications, including the automotive industry. Advanced ceramics can be used in various automotive components as seen in the picture, such as the engine parts, the exhaust systems, brakes, and sensors. To delve deeper with its application, we'll give you two examples. We have spark plug, ceramic insulator, and also the ceramic brake disc. So to start, we have here the table of contents. First, we will discuss to you about spark plugs. Next, we have the production process of these ceramic insulators of these spark plugs. Next, we have the second example, the ceramic brake disc and its production process. And also, we will discuss to you why these advanced ceramics are used in the automotive field. Next, as I've said earlier, we will have a short presentation for the journey or experiences of us too as a ceramic engineering student. Now, let's start with the first example, the spark plugs. So, spark plugs are the source of ignition, or as the spark. It supplies the spark that ignites the fuel or air mixture, creating the explosion which makes the engines produce power. As shown in figure 2, we have the ceramic spark plug parts and its insulator. We have the connector, the ceramic insulator, the gasket, and the electrode. In the ceramic insulator, we have the rib part and the nose. So these ceramic insulators prevent high voltage from shorting to the ground, and it removes heat from the combustion chamber. So the insulators used in the modern spark plugs are typically made of advanced ceramics such as the alumina ceramics, silicon nitride, and the zirconia. Next, we have here the spark plug ceramic insulator making process. So the making process of the ceramic insulator starts with the material preparation, followed by the molding, pressing, the contour grinding. Next, we have the firing for around 1480 degrees Celsius, and lastly, the finishing. Here we have the detailed production process for the ceramic insulator. First, we have the ceramic material preparation of alumina, binders, and additives. So this ceramic material in liquid form will be poured into the rubber molds, and the special presses automatically apply by the hydraulic pressing to the rubber molds, to be followed by the special contour grinding by the machines to give the final exterior shape of the insulator. Next will be the firing in tunnel kiln for the bonding of the ceramic particles together. After the firing, we will have the applying for the identifying marks and glaze. So the insulators may be fired again after identifying marks and glaze are applied. So take note that this process will utilize a computer controlled techniques to ensure the quality and the efficiency of the ceramic insulator.
Now let's move on to the ceramic brake disc manufacturing process. Have you ever wondered how the ceramic brake discs are manufactured? Well, the first step is the mixing of raw materials. It all begins with the right materials. The mix of initial ingredients is 2 components long, carbon fibers and phenolic resin. The fibers are carefully chosen for length and thickness in diameter, while the resin is in solid granular form. The second step is molding. The ingredients are mixed together in a proprietary formulation and then loaded into a steel mold. Removable cores are fitted to provide the radial vents necessary to expedite heat rejection during brake applications. The mold halves are closed, pressure and heat are applied. When the molding dies are opened and the cores are extracted, a near-net shaped brake rotor emerges. The third step is pyrolysis. The serious business begins when the molded rotors are placed with other like parts in an oven with the ability to maintain an oxygen-free environment at high temperature. In addition to numerous rotors, a quantity of solid silicon is placed in the oven. Nitrogen is pumped in to displace the air and the temperature dial is set for 1000 degrees Celsius. That temperature is maintained for many hours, during which the silicon becomes a liquid and pyrolysis occurs. The silicon gradually migrates into the pores of the parent material by capillary action, and the original carbon and phenolic material are transformed into silicon carbide, a hard and highly heat-resistant ceramic substance. The fourth step is machining. After the oven cools to room temperature at a controlled rate, the rotors are removed and machining operations begin. The inner and outer diameters, mounting location, and braking faces must be finished with utmost accuracy to assure excellent braking performance with minimal noise and vibration. Grinding operations with diamond tools achieve the desired dimension. The small lateral vent holes in the rotor faces are produced with an ultrasonic drilling process. The fifth step is coating. A coating is applied to all surface of the CCM brake rotor to provide oxidation protection. The sixth step is assembling. The center or hot section is attached to the CCM rotor with stainless steel screw, nut, and anti-rattle hardware. Some axial and radial movement between the metal hot and CCM rotor must be provided because the two components have drastically different temperature expansion rates. Anti-rattle spring allow this movement while preventing noise and vibration. After the retention nuts are properly torqued, each fastener is marked with paint to indicate that the step has been complete. The last step is quality control inspection. During a quality control inspection, the finished brake rotor's lateral runout and other pertinent dimensions are verified. Various pieces of information, such as batch number, to provide a means of tracking the rotor in the future, minimum acceptable mass, and minimum rotor thickness are printed on the metal hat. Why the ceramics are good material for automotive application? Well, advanced ceramics, or also known as engineering or technical ceramics, are a class of material that exhibit exceptional properties, such as high temperature resistant and durable. Second, it is lightweight and has high strength. And lastly, it is very resistant and offers superior performance. This is our reference, and that's all for the discussion of advanced ceramic processes.
After our discussion on advanced ceramics in the automotive field and their manufacturing processes, we'd like to present our journey as ceramic engineering students at MSU-IIT. So our education includes theoretical learning, webinars, forums, and hands-on experiences. OGT programs and plant tours have also enhanced our practical skills. In this presentation, we'll share memorable moments and practical encounters that have shaped our understanding and passion for ceramics. Join us as we take you on a journey through our experiences at MSU-IIT. First, we have classes like lectures and our laboratory hands-on works. So, enrolling in a comprehensive range of specialist ceramic engineering courses, we've acquired in-depth knowledge of ceramic materials, processing techniques, and engineering principles. So, we are also engaged in practical laboratory sessions to develop hands-on skills. Next, we were able to participate in seminars, webinars, and other academic and research forums, and we've gained exposure to cutting-edge research and advancement in ceramic engineering. We were able to interact with renowned experts and researchers, fostering intellectual growth and expanding knowledge horizons. Here we presented to you our pictures and our certificates for the following seminar. Aside from academic growth, we were also able to engage in academic organizations, gatherings, and social outings in which we were able to foster connections and collaborations with fellow ceramic engineering students and to our professors. And also, we were able to exchange experiences, insights, and academic interests in an informal setting. Here we have the Menaholma 2023, a Department of Materials and Resources Engineering Technology program. Next, we have the 50th anniversary of the Ceramic Training Center and also our General Society assemblies.
Visiting Cebu for the first time, I had the incredible opportunity to embark on a ceramic plant tour. The tour was not only my first experience of witnessing the intricate process of different ceramic production, but also marked my first ride on a ship. As we boarded a vessel, I was filled with a mix of excitement and anticipation. The sway of the ship and the vast expanse of the ocean created a sense of adventure. Upon visiting different ceramic plants, I was amazed by the process involved in creating different ceramic materials. The tour provided me with a new knowledge of different production processes, quality checking involved, and different environmental management systems. Aside from plant tour, we also indulged in a delicious buffet feast. From mouth-watering seafood dishes to succulent grilled meats, I savored every moment of gastronomic experience. We embarked on an adventure to Magellan's Cross, a historic landmark in Cebu. Exploring the nearby attraction and immersing myself in vibrant ambience of the area left me with unforgettable memories. Before bidding farewell to Cebu, I made sure to pick up some beautifully crafted souvenirs, serving as a reminder of my incredible journey and the diverse experience I had encountered. During my on-the-job training at Holcim Philippines Lugayat plant, I had the opportunity to work in the quality assurance department of this renowned cement manufacturer. I was immersed in a dynamic and fast-paced environment where attention to detail and precision were paramount. I participated in various quality control processes, such as conducting laboratory tests on raw materials, monitoring production parameters, and analyzing samples to ensure compliance with industry standards. Additionally, I work with experienced professionals, learning from their expertise and gaining valuable insights into the intricacies of cement manufacturing. This hands-on experience not only deepened my understanding of quality assurance principles but also sharpened my problem-solving skills and instilled in me a strong sense of accountability. Overall, my on-the-job training at Holcim Philippines Lugayat plant was an invaluable opportunity that provided me with practical knowledge and skills, setting a solid foundation of my future career in the industry. That's all for our video. Thank you for watching.